Hi friends, my name is Maruti and I'm the co-founder of Cracku. In this video, we'll be looking at the video solutions for LRDI section of the third slot of CAT 2023. So try to answer the question on your own. If you're not able to get it, then look at the video solution. If you have any doubts with respect to any of these LRDI questions, please do comment below the video. I look at all the comments and I'll try to answer them to the best of my ability. In this question, we are told that there is an air conditioner company which has 4 dealers D1, D2, D3 and D4. Each one of them sell ACs which are of two types, window and split, and each of these is also of two different types, inverter and non-inverter. We have been given some clues. Based on this, we have to figure out how many window inverter, window non-inverter, split inverter and split non-inverter did each of the 4 dealers sell. To do that, let us first draw a table. The table will look something like this. It will have some rows and columns. It will be probably like this. This will be D1, this will be D2, this is D3, this is D4, and this is total. This is the window ACs, this is inverter, and this is non-inverter. This is for the split AC, this is inverter, and this is non-inverter. Now let us look at the information that is given. We are told that every dealer sold at least 2 window ACs. So the window AC of D1, D2, D3, all of them is greater than or equal to 2. D2, D3 and D4. D1 sold 13 inverter AC. So this would imply that if he sold P window type inverter AC, the number of split type inverter AC he sold is 13 minus P. D3 sold 5 non-inverter AC. So D3, if this is Q, the number of split non-inverter AC is 5 minus Q. We were also given some information over here. 25% were window variant. So over here, this is 25%, the window variant, and this will be the remaining 75%. This would imply that the total number of split AC sold is 3 times that of the window AC sold. So if you assume that the total number of window AC sold is A, the total number of split AC sold will be 3A. Similarly, we are told that among the inverter ACs, that is if you are looking at the window variant of inverter ACs and the split variant of inverter ACs, 20% were the window variant. So if this is 20%, this will be 80%. Or again, if you are assuming that this is equal to B, the split inverter AC will be 4B. Next, every dealer sold at least 2 window ACs. We have already written that. D1 sold 13 inverter ACs. So if the inverter window is P, split inverter will be 13 minus P. D3 sold 5 non-inverter AC. So if D3 sold Q non-inverter window ACs, it will be 5 minus Q of split non-inverter ACs. A total of 6 window non-inverter AC, okay, 6 window this is 6, okay, and 36 split inverter AC. So this is 36. So if 4B is equal to 36, the value of B will be equal to 9. So this is equal to 9. So the total number of window ACs that are sold is 9 plus 6, which is 15. Therefore, the total number of split AC sold will be 3A, which is 45. This would imply that the total number of non-inverter split ACs will be 9, which is 45 minus 36. The number of split ACs sold by D1, split ACs sold by D1, okay, this is twice the number of window ACs sold by D1. Do we know the number of window ACs sold by D1? We don't know that, because we don't know how many non-inverter window ACs and non-inverter split ACs that D1 has sold. D3 and D4 sold an equal number of window ACs. So window AC of D3 is equal to window AC of D4, okay. And this number was 1/3 the number of similar ACs sold by D2. So this is equal to window AC of D2 divided by 3. What does this imply? It first implies that the number of window ACs sold by D2 has to be a multiple of 3. we know that each of them has sold at least 2 window ACs. So the window AC sold by D2 will have to be at least 6, because otherwise window ACs sold by D3 and D4 will be less than 6 by 3, that is 2. So it is either 6 or 9 or 12 or 15, because the total number of ACs sold, the total number of window ACs sold is 15. Clearly it cannot be 15, because if this is 15, D3 will be 5, this will be 5. So the total number of window ACs sold by D2, D3 and D4 is already 25. So this can't be 15. For the same reason, it cannot be 12, because if it is 12, this will be 4 and 4. So the total number of window ACs sold by D2, D3 and D4 will be 20. Can it be 9? If it is 9, the total number of window ACs sold by D3 and D4 will be 3 and 3. So the total number of ACs sold by D2, D3 and D4 will be equal to 15, which is fine. However, that would imply that the window ACs sold by D1 will be equal to 0. That also is not allowed, so this can't even be 9. So the only possibility is that D2 sold 6 window ACs. This would imply that D3 sold 2 window ACs. This would also imply that D4 sold 2 window ACs. And therefore, the number of window ACs sold by D1 will be 15 minus 10, which is equal to 5. D2 and D3 were the only ones who sold window non-inverter ACs. Window non-inverter ACs were sold only by D2 and D3. So this will be 0. This will be 0 by D1 and D4. This would imply that the number of window inverter ACs sold by D4 has to be 2, because the total number of window ACs sold by D4 is 2. This would also tell us that the number of window inverter ACs sold by D1 has to be 5. So the value of P is 5, so this will be 8. The number of these ACs sold by D2, okay, was twice the number of these ACs sold by D3. The total number of non-inverter ACs sold by D2 and D3 of window variant is 6. If D2 sold twice that of D3, this has to be 4, and this will have to therefore be equal to 2. This would imply that the number of inverter ACs of window variant sold by D3 is 0, because the total window ACs sold by D3 is 2. The total number of window inverter ACs sold by D2 will also be equal to 2, because this is equal to 6. So for window variant, we have completely filled the table for D1, D2, D3, D4 across inverter and non-inverter type. Let us try to do the same for even split ACs. D3 and D4 sold an equal number of split inverter ACs. D3 and D4 sold an equal number of split inverter ACs. So this is P, this is P. This number was half the number of similar ACs sold by D2. So this is 2P. What we know is that 8 plus 2P plus P is basically the sum of this column, which is the total number of split inverter ACs sold by the 4 dealers. That is equal to 36. So this will be equal to 36, or 4P is equal to 28, or the value of P is equal to 7. So this is 7. This is 7. And this is 14. This is 5 minus Q, so that actually is equal to 3. Because Q is equal to 2, so this will be equal to 3. Let us go through all the clues and let us try to see if we have used all the clues. Or otherwise, we'll try to fill the table. Every dealer sold at least 2 window ACs. This is completely used up, because we know all the information about window ACs. D1 sold 13 inverter ACs. Okay, this D1 sold 13 inverter ACs, that is 5 plus 8, that is used up. D3 sold 5 non-inverter ACs, that also is used up. A total of 6 window non-inverter AC, okay, and 36 inverter ACs were sold, split inverter AC in the city. This also is used up. The number of split ACs sold by D1 was twice the number of window ACs sold by it. The number of window ACs sold by D1 is 5. Therefore, the number of split ACs sold by D1 has to be 10. So this will be equal to 2. This also is used up. D3 and D4 sold an equal number of window aces. That is 2, both of them sold 2 window aces, and this number was equal to 1/3 of the number of similar aces sold by D2, which is equal to 6. Like we mentioned earlier, window aces, we know exactly how many were sold. D2 and D3 were the only ones to sell window non-inverter aces. That is fine. They are 4 and 2. The number of these aces sold by D2 was twice that of the number of aces sold by D3. This also is used up. D3 and D4 sold an equal number of split inverter AC. This number was half of the similar number sold by D2. That also is used up. So basically, we don't know the number of non-inverter ACs sold by, of split variant sold by D2 and D4. Let us assume that this is A. This will therefore be equal to 4 minus A, because the sum of this column has to be equal to 9. Let us go ahead and answer the questions that follow. How many split inverter ACs did D2 sell? Split inverter ACs that D2 sold is equal to 14. What percentage of ACs sold were the non-inverter type? The non-inverter ACs that were sold is 6 plus 9, and the total number of ACs sold is 16, which is 15 plus 45. So this percentage is 15 by 60, which is equal to 25%. What is the total number of ACs sold by D2 and D4? D1 sold how many? 5 plus 8 plus 2 is 15. D2 sold how many? 2 plus 4 plus 14 plus A is 20 plus A. D3 sold how many? 2 plus 7 plus 3, which is equal to 12. D4 sold how many? 2 plus 7 plus 4 minus A, which is equal to 13 minus A. So the total number of ACs sold by D2 and D4 will be the sum of 20 plus A and 13 minus A, which is equal to 33. Which of the following statements is necessarily false? D2 sold the highest number of ACs. D2 did sell the highest number of ACs. That is definitely true, because out of all of these 4 numbers, 20 plus A has to be the highest. So this is true. We are looking for a statement which is necessarily false. D4 sold more split ACs as compared to D3. D4 sold how many split ACs? D4 sold 11 minus A, and D3 sold 10. So is this statement that 11 minus A, is it true or false? It is sometimes true and sometimes false based on the value of A. A can be 0, A can be 1, A can be 2, A can be 3, or A can be 4, because 4 minus A exists. So sometimes this is true, sometimes it is false. So sometimes true or false. So this is not necessarily true or necessarily false. D1 and D3 sold an equal number of split ACs. D1 sold 10, which is 8 plus 2. D3 also sold 10, which is 7 plus 3. So this is definitely true. D1 and D3 together, okay, sold more ACs than D2 and D4 together. How much did D1 and D3 sell together? D1 and D3 sold 15 plus 12, which is 27. D2 and D4 sold 33. 27 is definitely not greater than 33. 27 in fact is actually less than 33. So this is definitely false. So the only statement which is always false is option D. Option B is sometimes true, sometimes false, but we are looking for the statement which is necessarily false. If D3 and D4 sold an equal number of ACs, what is the number of ACs sold by D3? 12. What is the number of ACs sold by D4? 13 minus A. If 12 is equal to 13 minus A, then what was the number of non-inverter ACs sold by D2? So A will be equal to 1. We are looking for the number of non-inverter ACs sold by D2, which is 4 plus A. 4 plus A will therefore be equal to 5, which is option B. In this question, we are told that there are 4 teams, team 1, team 2, team 3, and team 4. They patrol the streets across the cities A, B, C, D, E, and F as shown in the map. And they start from 9 a.m. and they continue till 12 noon. From one station to another station, it always takes 30 minutes to cross. They start at station A and they come back to station A by 12. We are essentially required to figure out where each of these 4 teams are there at every half an hour interval. So let us draw a table. The table will contain some rows and columns. It will look something like this. This is at 9, this is at 9:30, this is at 10, this is at 10:30, this is at 11, this is at 11:30, and this is at 12. This is for team 1. this is team 2, this is team 3, and this is team 4. At 9 o'clock, all of them start from station A. So this is A, and A. And at 12 o'clock noon, they all come back to A. So this is also A, and A. We are given some clues. Let us go through all the clues. We are told that none of the streets has more than one team traveling in any direction at the same point. So basically, if at some point we figure out that somebody is going from C to D, at the same point, nobody will go from either C to D or from D to C. Teams 2 and 3 are the only ones in stations E and D at 10 a.m. So at 10 a.m., team 2 is at E and team 3 is at D. This would imply that team 1 is not at E or D at 10. Similarly, team 4 is not at E or D at 10. Now, where is E? E is somewhere over here. D is somewhere over here. If somebody is coming to E from A with a gap of 1, the only possibility is that this person has come through F. Because if this person has come through C, he would take 1, 2, and 3 stops. There are at least 2 stops in the middle, C and D. If there is only 1 stop, the only possibility is that this guy has gone to F. Similarly, if somebody has come from A to D with 1 stop in the middle, that stop will be either E or it will be C. So this will be either E or C. Let us look at the next clue. Teams 1 and 3 are the only ones in station E at 10:30. So 1, this is E, and 3. So this is E. Now we can immediately say that this guy will not be E over here, because team 3 is going from D to E from 10 to 10:30. Team 2 cannot go from E to D. So this will not be D, because from E to D, team 2 cannot go, because team 3 is going from D to E between 10 and 10:30. So between 10 and 10:30, we know that at 10 o'clock, team 2 is in E. So at 10:30, it cannot be at D, because of the rule that we have that at no point are 2 teams going to be on the same street. Next, what do we have? We have this one. Teams 1 and 4 are the only ones in stations B and D at 11:30. So this is B and this is E. So the remaining 2 are not B and D. Notice that from 11:30 to 12, they have to come back to A. And what are the points from which you can come back to A? You have to be either F, or you have to be C, or you have to be B or E. We know who is at B and D at 11:30 a.m. This would imply that team 2 and team 3 are at C and F at 11:30 a.m. because they have to come back to station A at 12 o'clock. Now teams 1 and 4 are the only ones that patrol the street A and E. So A and E are there only over here, either team 1 or team 4. This would immediately imply that from 9 to 9:30, because team 3 doesn't have the patrol from A to E, this has to be C only. Let us look at the next clue. Team 4 never passes through B, D or F. So this is not B or D or F. This is not B or F. This is not B or D or F. This is not B or D or F. Okay, B, D and F are not present in T4. Now immediately we can figure out that at 9:30 from A, if you're looking at team 4, it cannot be at F because team 2 is at F. It cannot be at C because team 3 is at C. If you're looking at T4, it cannot be at B because team 4 has never gone to B. This would imply that it has to be definitely there at E. So this has to be definitely E. This would imply that at 9:30, team 1 has to be at B. This is the only possibility. So this will be B. So at 10 o'clock, team 1 has to come back to A because from B there is only one connectivity which is back to A. So this has to be A. From A they went to E, and from E they have to come back to B. So they are at E at 10:30, they are at B at 11:30. What is the only possibility? If there is only one stop between E and B, that has to be A. So they have to be at A at 11 o'clock. So for team 1 we are completely done. We have figured out all the stations that team 1 has encountered. We can also figure out the same for team 4 because you can see that there are a lot of stations they haven't gone to, team 4. So team 4 at 9:30 a.m. they are at E. So at 10 o'clock they'll either be at A or D or F. But team 4 has never gone to D or F. So this has to definitely be A. So at 10 o'clock team 4 is at A. So at 10:30 they have to be either at C or E or F or B. Now it cannot be at E because team 1 is at E, so it is going from A to E from 10 to 10:30, and team 4 does not go to D or F or B. So this would imply that team 4 has to definitely be at C. So this has to be C. From C, because team 4 doesn't go to D, it has to again go back to A. So this has to be A. So for team 4 also we are completely done. At all times we have figured out where team 4 is. We have to figure out for team 3 and team 2. Team 3 we know where team 3 is at 9, 9:30, 10 and 10:30. At 10:30 a.m. it is at E. And at 11:30 a.m. it is either at C or at F. Now, is it possible for somebody to go from E to F with one stop in the middle? The only possibility is that if they go from E to A and from A to F. But you notice that team 3 does not go through A. So this doesn't exist. If this doesn't exist, for somebody from team 3 to go from E to F in one stop in the middle is not possible. So this would imply that this has to definitely be C and this has to be D. And if team 3 is at C at 11:30 a.m. and it is going from C to A between 11:30 and 12, this has to definitely be F. Now if you are looking at team 2, we know that team 2 is at A, F and E at 9, 9:30 and 10. It is at E at 10 o'clock. At 10:30 it will either be going from E to A, or it will be going from E to D, or it will be going from E to F. One thing we know is that team 2 did not go through the EA path. The EA path was not patrolled by them. It was patrolled only by teams 1 and 4. So it has to go through either ED or it has to go through EF. We know that it did not go through ED because the DE path was being patrolled by team 3 at that time. So it cannot be ED, so this has to be F. So the only thing remaining is where is team 2 at 11 o'clock. At 10:30 it is at F. At 11:30 it is again back at F. Now what is the possibility for this? It can go from F to A and then come back to F. This is one possibility, or it can go from F to E and again come back to F. Both of them are possible. So this can be either A or F. With this table, let us go ahead and answer the questions that follow. Which among the following stations is visited by the largest number of times? Is visited the largest number of times. Team C, how many times does it occur in the table? It occurs 1, 2 and 3 times. Station E, how many times does it occur? It occurs 1, 2, this is A or E, 1, 2, 3, 1, 2, 3, 4, 5. So it is either 5 or 6. Basically based on this situation. Station D, it occurs 1 and 2 times. Only 2 times I think. Station F occurs 1, 2, 3 times. Let me write it down over here because if this might get confusing. This is F, so it occurs 3 times. So the possibility is that the correct answer is station E. It is visited either 5 or 6 times, clearly the maximum number of times. How many times do the teams pass through station B in a day? Station B is passed once, twice, 2 times. Which team patrols the street connecting D and E at 10:15? That has to be team 3. It is going from D to E between 10 and 10:30. So this has to be team 3. How many times does team 4 pass through station E in a day? Team 4 passes through E once and twice. How many teams pass through station C in a day? Station C is passed by team 3 and by team 4. Team 3 passes 2 times and team 4 passes once. These are the only 2 teams which pass through station C. So the correct answer is 2 teams.
Google search Cracku free cat mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 cat aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question, we are told that there is a coaching class in which some students register online, some of them register offline, and we get the total number of registrations. Nobody registers online and offline, so the total number of registrations is the sum of online plus offline. We need to calculate the number of online, offline, and total registrations across the 5 months from January to May. So let us first draw a table. The table will look something like this. It will have 5 rows and 4 columns. It will be something like this. This is January. This is February, this is March, this is April, and this is May. This is the online registrations, this is the offline registrations, and this is the total. What do we know about online and offline registrations? Across the month, we know that online registrations, offline registrations, and total, we are given the median and mean and minimum and maximum. We are not given the mean, we are given the minimum, maximum and median of online, offline and total. For online, the minimum is 40. So we have 40 over here. The maximum is 100. So we have 100 over here. And we have median, which is 80. So 80 will be here. So the remaining 2 months, one of them will be less than or equal to 80 and greater than or equal to 40. So it will lie between 40 and 80. And the other one will lie between 80 and 100. So the other one will be 80, 90 or 100. For offline, the minimum is 30, the maximum is 80, and the median is 50. So we'll have one number over here between 30 and 50. So it can be either 30 or 40 or 50. One number will be over here. So that will be either 50 or 60 or 70 or 80. For total, we are told that the minimum is 110, the maximum is 130, and the median is 120. So one number will be between 110 and 120. So it will be either 110 or 120. And one number will be over here, which is between 120 and 130. So it can be either 120 or 130. This is the information that is given. Let us look at the clues that are given. Every month, both online and offline registrations are multiples of 10 that we already know. In January, the number of offline registrations was twice that of online registrations. So over here, this will be 2A and this will be A. And the total will be equal to 3A. If you're looking at the total, the only way you get a multiple of 3, because the total is either 110 or 120 or 130, is if that number is 120. So over here, we'll get 120 as the total. This will be 40 and this will be 80. We got offline of 40, so that is over here. So the only number that is remaining in offline will be the number that lies between 50 and 80, both of them included. So it can be either 50 or 60 or 70 or 80. We are told that in April, the number of online registrations was twice that of offline registrations. Okay, 1 second. I think we made a mistake over here. Here we are told that the number of, in January, number of offline registrations was twice that of online registrations. So this has to be 80 and this will be 40. Similarly, in April, it was the other way around. The number of online registrations was twice that of offline registrations. So if you assume that this is 2A and this is A, again we are getting this to be 3A, which is a multiple of 3. The only multiple of 3 between 110 and 130, which is also a multiple of 10, is 120. So this has to be 120. So this will be 40 and this will be 80. What else do we know? the number of online registrations in March was the same as the number of offline registrations in February. So if this you assume to be A, this also is A. The number of online registrations in March is equal to the number of offline registrations in February. The number of online registrations was largest in May. So this would imply that this has to be 100 over here. And because we want the total to be less than or equal to 130, the number of offline has to be 30 over here. Because if it is 40 or 50 or 80, the total will be 100 plus that, which is greater than 130. And this will be 130. By going through the clues for the first time, this is what we are able to fill out in the table. So if you're looking at the online, offline and total that is filled up, we filled up 40 in online. This 40 is filled up. We filled up an 80 in online. This 80 is filled up. We filled up a 100 in online. In online, what did we fill up? We filled up an 80. This one we filled up. We filled up a 40. This one we filled up. We filled up a 30. The two numbers that are yet to be filled up is this 50 and this number which lies between 50 and 80. So the value that A can take will be either 50 or 60 or 70 or 80. Now we have a number over here which is the value of Y. Let this be equal to Y and let this be equal to Z. What are the values that Y can take? If you are looking at online numbers, we filled up a 40. We filled up a 80. We filled up a 100. This A that we are talking about lies between 50 and 80. So this will be where A will come. A will be the number which is less than or equal to 80. And this will be the place where Y will come. This Y over here, that will lie between 80 and 100. So A will be either 50 here or 60 here or 70 here or 80 here. And Y will be either 80 or 90 or 100. So Y will be 80 or 90 or 100. This is as far as the online segment is concerned. Why exactly are we saying that A will be either 50 or 60 or 70 or 80? Because if you are looking at the offline number over here, we have figured out 80, we have figured out 40, we have figured out 30. There are only two numbers left. They are A and Z, and both of them will lie between 50 and 80. This is where A and Z will lie. So A will be either 50 or 60 or 70 or 80. So in online also there is an A, so that will be over here. So this number has to be Y. But one thing that you have to remember is A plus Y is the total for February. Now A plus Y is definitely less than or equal to 130 because the total is either 110 or 120 or 130. The smallest possible value of A plus Y will be over here. If A is the minimum possible, which is 50, and Y is the minimum possible, which is 80. So A will be over here 50, Y will be 80, this also is 50, and 80 plus 50 is 130. What is the value of Z? The value of Z has to be 60 because the minimum value of the total of 110 did not occur in this table. We got two 120s, we got two 130s, but the minimum value of 110 did not occur. So this has to be 110. This would imply that this Z has to be 60. Let us look at the questions that follow. What is the total number of registrations in April? The total number of registrations in April is 120. What is the number of online registrations in January? The number of online registrations in January is 40. Which of the following statements can be true? The number of offline registrations was smallest in May. The number of offline registrations was smallest in May. This is true. The total number of registrations was smallest in February. This is not true. The total number of registrations was smallest in March. So only one is true. What best can be concluded about the number of offline registrations in February? The number of offline registrations in February is equal to 50. Which pair of months definitely had the same total number of registrations? January and April. January is 120, April is 120. So yes, they had the same number of total registrations. February and May. February had 130, May had 130. So they also had the same number of registrations. So both 1 and 2 will be the answer. In this question, we are told that there are 3 female students, Amala, Kohli and Rini, and there are 3 male students, Biman, Matthew and Shyamal. They're in a course. The course has 2 components, project and test. Project is done in a group of one male and one female, and both of them get the same score in project. In test, all of them are marked individually. Project is given some weightage, test is given some weightage. The sum of these two weightages is equal to 1, and based on it, we are getting an aggregate score for the 6 people. So let us first draw a table. The table will have some rows and it will have some columns. It will look something like this. Here we'll have the 3 female students, Amala, Kohli, and Rini. And we have the 3 male students, Biman, Matthew, and Shyamal. We have a score in project, we have a score in test, and we have the aggregate score. The sum of the weights of the project and the test will be equal to 1. The projects are done in groups of 2, with each group consisting of a male student and a female student, and both the group members get the same score in the project. The minimum and maximum and the average of both the project and test scores were equal. They are 40, 80, and 60. In project, there are 3 groups and there are 3 marks, because both the students who are part of the group get the same marks. If you are told that the minimum is 40, it would mean that 2 people got 40. 1 man and 1 woman. The highest is 80, so 2 people got 80, 1 man and 1 woman, that project got 80. And the average is 60, which would essentially imply that the third team got 60 in the project. In test, we are told that the lowest is 40, the highest is 80, and we have 4 more scores. The total average is 60. So the total marks scored by the 6 people is 6 into 60, which is 360. Out of which we are able to account for 140 and 180. So we need to account for a remaining of 240. The test scores of all the students were multiples of 10. 4 of them were distinct and the remaining 2 were equal to the average test scores. The average test score is 60. This would imply that 2 people scored 60. So we have 140, 2 60s and 180. So if you subtract 2 60s, the sum of the remaining 2 will be equal to 120. And both of them are multiples of 10 and both of them have to be distinct from 40, 60, 80. The only possibility is that one of them scored 50 and the other one scored 70. These are the test scores. Amala's score in project was double that of Kohli in the same. Amala's score therefore has to be 80 and Kohli will be 40. And Rini is the other person, other woman, the only woman remaining. So she has to score 60. Because this 40, 60 and 80 are the scores of 3 women. 40, 60 and 80 are the scores of 3 men also. But Kohli scored 20 more than Amala in the test. So if Amala scored A in the test, Kohli scored A plus 20. Now what are the values that A can take? This 20 difference can be either 40 and 60. Or it can be 50 and 70, or it can be 60 and 80. Any one of these 3 cases are possible with respect to the test scores of Amala and Kohli. Yet Amala had the highest aggregate score. So the aggregate score of Amala is the highest. Shyamal scored the second highest in test. So Shyamal scored 70. If Shyamal is scoring 70, this case will not exist. Because now Amala cannot score 50 because then Kohli will have to score 70, but that is not possible because Shyamal scored 70. He scored 2 more than Kohli, but 2 less than Amala in the aggregate. So if you assume that Kohli's aggregate is P, Shyamal's aggregate is P plus 2, and Amala's aggregate is P plus 4. Biman scored the second lowest in the test. Biman scored second lowest, so Biman scored 50. So we have accounted for 50, we have accounted for 70. And the lowest in the aggregate. So this has to be lowest. Matthew scored more than Rini in project. Rini scored 60, so Matthew has to score 80, but less than her in test. So this test marks has to be lesser than Rini. Now if you look at who scored 80 in project, Amala scored 80, Matthew scored 80. but the highest aggregate belong to Amala. This would imply that Amala has to score more than Matthew in test. If Amala scored 40 in test, there is no way she would score more than Matthew, because Amala scored 80 in project, Matthew scored 80 in project. If Amala scores 40, which is the lowest score in test, she cannot have the highest aggregate. So this case is not possible. This would imply that Amala scored 60 in test, therefore Kohli scored 80. Now we have taken 160 out and we have taken 180 out. The only two numbers remaining are 40 and 60. Those two belong to Rini and Matthew. Matthew scored less than Rini, so Rini has to score 60 here. This would imply that Matthew scored 40. Using this, we can actually calculate the coefficients for project and test. How can we do that? Because the aggregate scores of Amala and Kohli differ by 4. Because if Kohli scored P in aggregate, Shyamal scored P plus 2 and Amala scored P plus 4. So if you assume that the coefficient of project is, say, P, the coefficient of test will be 1 minus P. So the aggregate score of Amala will be 80 into P plus 60 into 1 minus P. The aggregate score of Kohli will be 40 into P plus 80 into 1 minus P. And the aggregate score of Kohli is 4 less than that of Amala. So this plus 4 will be equal to this. You can simplify this as 40P is equal to 20 into 1 minus P plus 4. Or this would imply that 60P is equal to 24, or the value of P is equal to 0.4. So the coefficient of the project will be 0.4 and the coefficient of the test is 0.6. Using this, we can calculate the score of Shyamal in project. How can we do that? Because we know that the aggregate score of Amala is 2 more than the aggregate score of Shyamal. What is the aggregate score of Amala? Now we can calculate it. It will be 80 into 0.4 plus 60 into 0.6. This is 32 plus 36, which is equal to 68. So the aggregate score of Amala is 68. Aggregate score of Shyamal therefore will be 66, which is 2 less than that of Amala. And aggregate score of Kohli will be 2 less than that of Shyamal, which is 64. So if you assume that Shyamal scored S in project, S into 0.4 plus 70 into 0.6 is equal to 66. 70 into 0.6 is 42. So S into 0.4 is equal to 24, or the value of S is equal to 60. So this is 60, this would imply 40. We can fill out the aggregate scores for the remaining people also, but we'll do it if it is necessary. Let us go ahead and answer the questions that follow. What is Rini's score in project? Rini scored 60 in project as well as test. So the answer is 60. What is the weightage of the test component? The weightage of the test component is 0.6. What is the maximum aggregate score by one of the students? The maximum aggregate score was received by Amala, that is 68. What does Matthew score in the test? Matthew's score in the test is 40. Which of the following pairs of students were part of the same project group? Amala and Biman. Amala and Biman were not part of the same group. Amala partnered with Matthew. Kohli and Matthew. Again, Kohli and Matthew are not part of the same group because Kohli and Biman were part of the same group. So the correct answer is neither 1 nor 2.
We at Cracku provide all the previous year CAT papers along with many other MBA examinations such as XAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.